Thank you. I do want to thank you all for being invited back. How many of you have heard of Rayburn, Virginia? I used to live there, okay, when I was doing my doctorate here, and a lot of my success in life has been due to having worked with Roy Blazer. He's the one that brought me into pasture ecology. I was actually trained as a wildlife ecologist, but in the 70s you couldn't get a job in wildlife, so I had to find a job. And he took me from working with white-tailed deer to cattle and sheep and goats and things like that. Then you're going to hear, a lot of you know Harlan White. Harlan White was on my committee, and he was a major mentor for me, especially from the extension side. When I grow up, I hope I can be like Harlan White. So that's been one of my goals in life. So let's get on with the topic here. This is going to be a quick introduction. I'm going to hit a lot of topics, and it'll be quick. But we can, if you ever want to go deeper, that's an option in the future. So we're going to talk about four of these building blocks: climate, plants, animals, soil, and humans. We're not going to talk a whole lot about climate because I'm just going to assume we're working within the climate here in this part of Virginia, okay? I may give some other examples. But principles. Joshua talked about principles. I'm going to hit on principles. There's an old saying that if we learn correct principles, then we can govern ourselves. And that's what Roy Blazer always tried to teach in his 4-H class. What are the principles that we need to know as a farmer that we can take out in the field and implement them in the field and develop our own system, the system that applies to our farm? So, all organisms and communities, now a community is a group of organisms that live together, okay, have an optimal environment, and they have limiting factors. It comes back to the old diminishing return curve. If you've seen that, I'm sure Groover's shown you this, somewhere in the years, that as you have an input, if that input is a limiting factor, over here on the left-hand side, as we increase that input, we'll come to some point where it's in the optimum range and we get no more value of adding that input. A lot of times we think of that as fertilizer. It could be temperature, water, available water. Any environmental factor can pretty much be put on that type of scale. And you look at some point it's a limiting factor, at another point we're in the optimum range. Now, organisms also differ in their response to the environment, and that's what allows for competition, or maybe I should say causes competition. But first of all, let's just look at this one. Probably all of you are familiar with this, that alfalfa needs a pH over 6.5, somewhere between 6.5 and 7, to be in that optimum range. If we drop below 6, alfalfa growth drops very quickly. It's very intolerant to low pH. On the other hand, if I have red clover, white clover, or bird's foot trefoil, they are quite tolerant of low pH, as long as they have the other things they need. So it just shows different species and their tolerance, in this case, to pH. Environmental factors often have upper limiting regions as well as lower critical values. The classic one that we work with every year is the cool season grass, the C3 grasses. If the temperature is below 40, they don't grow very well. Once we get the mean daily temperature up around 50, they're doing pretty well. Now, if my mean daily temperature is 50, what's my daily high probably going to be? It could be 70. On average in here, it's somewhere around 60. But yeah, it could be 70. If it's a clear day, clear night, then it might be 70. But on the average, it's close to 60. About 10 degrees above and 10 degrees below average. So the cool season grass, once we get to 70, it's pretty good growth between 50 and 70. As we go from 70 to 90, now a daily average for 90, that's pretty hot, isn't it? Okay, you think about the nighttime temperatures up in the 80s, the daytime temperatures up above 90. And those cool season grasses, the fescue and the orchard grass, it doesn't matter how much moisture you have in the soil, it'll be basically zero growth. On the other hand, if I have a warm season grass, over in Blackstone we like to pick on Bermuda grass. You don't have much Bermuda grass here yet, right? But you have crabgrass, don't you? Okay, so think of crabgrass. The crabgrass will follow this line pretty close. Very little growth down here below 60, but when I get up to that 90 degree temperature range, crabgrass will go great for you. And that's crabgrass. I mean, some of you may think of it as a weed, but it's actually one of the best forages we have if you manage it. And in conjunction with tall fescue, it's a good grass to reduce the endophyte toxicity. Okay. If we're pasture-based livestock producers, we're in the business of harvesting sunlight, solar energy. We're going to convert that solar energy using our livestock into products for people. We manage the plants for optimum solar interception. We want to manage the animals for optimum conversion. We're going to cycle the nutrients back into the soil, back to the landscape. And we want to make that business socially, economically, and environmentally sustainable. We are pasture system, ecosystem managers. Have you ever thought of that? Have you ever thought of yourself being an ecosystem manager? It is what you are, if you want to wear that hat. So sun to forage, forage utilization, that's grazing management, animal production, health, genetics, marketing for a cash input, or cash in our pocket. So solar energy powers the system. The nutrients are really what is capturing that energy. And we want to recycle them. So here's the flow, over to an animal product, the carbon cycle. If you ever think about carbohydrates, you ate a bunch of them over there, right? Sugar, starches. That's solar energy. Have you ever thought of that? That's really what it is. Okay. Complex diagram here, atmosphere. This is the nutrient cycle. Nutrients are going everywhere. That's what we're saying. We have the soil to work with, the plants above ground and within the soil, the animals. What we don't want are nutrients going into the groundwater or into the surface water. Where does your surface water go from here? Some of you go into the Roanoke, right? New River. Okay, the New River. You're going into West Virginia, ultimately into the Gulf of Mexico. So if you lose a pound of phosphorus, what does that cost you? It's about 50 cents. So you lost 50 cents, and the Gulf of Mexico just got 50 cents worth of phosphorus it didn't need. So there are two sides of this coin. One is we'd like to keep the coin in our own pocket, to keep our farm more sustainable economically, but also by doing that we can be better environmental stewards and not be contributing to a problem downstream. So let's talk about plants. From a pasture ecology side, we talk about them being producers. They harvest the sunlight. They, along with their bacteria, will fix nitrogen, and they're a major part of the nutrient cycle. Different plants have nutritional quality. Depends on the plant and the age. They may have anti-quality components. We've already talked about tall fescue. That's one of the main ones. Morphology. What does the plant look like and how does it grow? We're just going to touch on that. The simple answer is they're tall plants, they're short plants. Some have rhizome, rhizomatous growth. Some are just bunch grasses or legumes. We have fibrous roots, we have tap roots. These are all important characteristics that we need to learn about as we go through life with the plants out in our fields. Life histories. Are they perennial, biennial, annuals? Where do they fit within the successional stage or within the community of plants that we're working with out there? So, light interception and photosynthesis, that's what powers the system. But the forage growth rate varies over the year, doesn't it? Let's look at light interception first. Just using ruler height here. A lot of you have a pasture stick. If not, buy one out there at the desk. Okay, little sales pitch. But this is just looking at height. What would be the other factor rather than just height? Density. Thank you. So I'm just using height today to show the principle, but density is also important here and plays into it. So this line right here, May, notice that it takes about 10 inches of height to get up here close to 100% light interception. This line over here, September, it's closer to 4 inches of height to reach maximum light interception. Why is that? What's going on in May? Or let me say, what's going on the 21st of June? Give you a hint. Okay, the 21st of June is, the summer solstice. And where's the sun in the sky? It's at the highest point of the year. So when the sun's high in the sky, the sunlight can go deep into the stand, can't it? Over here in, I wasn't supposed to push that button. Over here in September, now there's the equinox, the fall equinox, September 21st, more or less, within a day or two. And now the sun's getting lower in the sky, and then as we go into October and November, it gets real low, doesn't it? So this is this is my grass, okay? In May, it gets to come in like this, but in the fall, it's coming in at an angle. So that's why, a shorter stand of grass in the fall catches the full sunlight, and you need a taller stand of grass, near the summer solstice to catch all the sunlight. Now, let's jump over to temperature. Review, cool season grass, maximum growth, at the low end around 50, at the upper end around 70, goes down to 0 at 90. Warm season grass, 60 to 90. And in our environment, we never see the upper end, luckily. Okay, water use efficiency. We call it evapotranspiration. It's just the combination of the words for evaporation and transpiration. So the cool season grass, the C3 grasses, they require more water than the tropical C4 grasses. So we have two relationships here. Response to air temperature and response to their need for water. And those two responses are what give us these two different growth curves. And those are pretty major differences in growth curves, aren't they? But it was only because of two major factors. Plus the sunlight. That sunlight coming in not only affects light interception, it also affects evapotranspiration. So that is also built in here, in these curves. But anyway, we get some fairly major differences based on the plant type and their response to the environment. That's what I'm trying to share with you here. Okay. Wanted to talk about some differences in forage species relative to their tolerance. Okay, this is the one I wanted. I blew the punchline. You're supposed to see this one first. Okay. Tolerance to long rest periods. Now, why is that interesting? There's a lot of talk and hype about mob grazing. And one thing they do in mob grazing is they talk about long rest intervals. Okay? What I want you to think of, there's a difference between stock density and rest interval. You need to separate them. In mob grazing, they like to lump them together, and that's fine. I want us to deal with principles, not with management systems. If you know the principles, then you develop your own management system. Chris can have his management system, and Ozzy can have her management system. So by knowing the principles, you make your own system. So some plants are tolerant to long regrowth periods, and that's tied in with shading. So they're tolerant also to self-shading. They're hay types, smooth brome, timothy, reed canary, on down, and especially native warm season grasses. These are generally upright grasses. They are very tolerant to long rest periods and self-shading. These plants are intolerant. Tall fescue, orchard grass, white clover. Now let's look at the other slide. Species differ in their tolerance to frequent close grazing. Same list, but we've just changed the management, and so these are intolerant, but these are tolerant. Now there are differences within each of those columns. These columns, some are more intolerant than others, and over here some are more tolerant. But let's go back here. If I have long periods, where can I use this intolerance? We have tall fescue here. If you have toxic tall fescue, the old-fashioned Kentucky 31, we can use this knowledge to our advantage. And this is where the long rest interval comes in. I'm just going to jump over to my old PhD dissertation. 30 years ago, what I found out with fescue in Blacksburg, if I cut one cut hay off there and then stockpiled it from June into December, it was amazing how much bare ground you got in between the clumps of fescue. No longer do you have a fescue lawn with tillards everywhere. You have clumps of fescue. Now, you could say, well, I wasted all that summer. Well, if you have toxic tall fescue and you have an alternative, that may not be bad. But by opening up that ground, grazing off the fescue, it was good, winter feed fescue, by the time December came. Graze that off in December and January, and then, having that bare ground in between the fescue allows frost heaving, and then I can do my frost seeding of clovers. And now the next year, as that clover develops in the stand, no longer do I have just a fescue stand. I have a clover fescue mix out there. On the other hand, if you want to keep your orchard grass nice and dense, you don't want to do that. And as we go back and look at some of the old orchard grass research, where they looked at cutting height on orchard grass, they weren't thinking, they were learning, okay? They didn't have the information we have today. With 40 years hindsight. Some of those orchard grass stands went out because they didn't cut them. And they accumulated forage, and the orchard grass self-shaded and lost tillers, and they lost the orchard grass stand because the orchard grass was not tolerant to shading. Now, okay, coming over here, if I want to develop white clover, it's very tolerant to frequent close grazing, and that's the classic way. If I need to develop more white clover in the stand, you may want to reduce your rest interval or tighten the grazing pressure. But would you do that necessarily in July and August? And I haven't lived in this area for a long time, so how hot is it here in July and August? I know it's warm. Okay, 80s, 90s? No, okay. So bottom line, this is a cool weather plant. If I really want to stimulate white clover, I want to put that management in either in the spring or in the fall when it's going to respond to that management, because it's now in the temperature range that it needs, plus I'm giving it the grazing management that it needs at the same time. To give it the management when it's not going to respond is not very meaningful, is it? Or not very useful to the plant. So we have to do the timing together. So soil drainage, some plants tolerate poor drainage, some tolerate excessive drainage. Alfalfa does not tolerate poor drainage. It needs 2 feet of well-drained soil minimum to produce, but it will tolerate excessively drained soils. I've seen alfalfa roots 12 feet deep in a gravel soil. Red clover, of course, does better in poorly drained soil, and the white clover does quite nicely in a shallow soil. So we want to manage light interception, top growth, energy reserves, root growth, and our harvested yield. Just a quick review, we need height and time of year. That's what determines light interception. Let's look at carbohydrate cycle. This is in tall fescue and white clover. This green line is the white clover, and the red line is the tall fescue. We've either cut it or grazed it tight, and then we've taken the cattle out of the pasture. Okay, I emphasize that point. And as the plants regrow, our carbohydrates come down and then come back up. I should have put in the forage height in this chart, and I apologize for not having done that. But basically, forage height is down here and is growing pretty much in a linear fashion, back up here from around 2 to 3 inches up here to 8 to 10 inches. Now, why is that information useful? Well, we want to have under good management, we want to let the carbohydrates get back up here to a high level so that when I graze again, the carbohydrates can get those leaves moving, so the leaves get back out there quickly and gain light. On the other hand, I can use this to set back a stand. Say I don't have the white clover in there, and I want to stimulate white clover, or let's say it's a hayfield and I want to do a no-till seeding of red clover, but I don't want to use herbicides because I'm organic. Okay? Well, I can graze it off tight, let that grass come back about halfway, which is an indicator that this is about pretty close to the bottom. Graze it again. Or broadcast seed out there if you don't have a no-till drill, and it's say here in September, you could broadcast your seed out there, graze it tightly with mob grazing. Yes, I'm hurting the fescue a little bit, but we're not going to cry over the fescue a whole lot, as long as I hurt it just a little bit. But we've given that, we've set back the fescue. It's going to take roughly twice the amount of time to come from 2 to 3 back up to 8 to 10 if I hit it at this point than if I we're doing the regular management. And that's one of those experiments you can try. I've done that on my own farm, not because I wanted to sometimes, but because I had to. I'd grazed off a field, and I wanted to move the cattle, and I actually had moved them to a second field, but the third field I had to get them to. I don't remember today why I couldn't get them there. It's probably the fence was down. So I brought them back into the field that was half grown, and I knew what was happening. I knew what was going to happen. And I saw it for several weeks after, how long it took it to regrow. Sir?
Does the time of day when you harvest the grass, whether you put grazers on it or you cut it for hay, matter? So,
Well,
in the afternoon or the morning, or does it matter?
okay, relative to this response curve, no, it doesn't matter, because this response is looking at what happens on a average basis below ground. No, what you're referring to is the sugar accumulation in the leaves. No, that will be higher in the afternoon. And if you have real high-performing cattle, there may be some merit to shifting them in the afternoon. But that's really getting advanced. Now, if you're making hay, that was the other point. In our haylage study, we are getting some data that suggests that on those samples that are cut after afternoon, somewhere in the 12 to 2 o'clock time period, we're getting a little bit better fermentation. And I would attribute that to the fact that we do have more sugar. Now you could say, well, why not at 4 or 5 o'clock, because that should be higher sugar yet. But no, if we cut at that time, then we've changed the whole time period when we end up baling that haylage. If I cut at noon, I might be able to bale that day. If I cut at 6, you're not going to bale until the next day. So that haylage is sat out in the field overnight, whereas a little bit earlier, we're able to get it up the same day. Okay, keeping on with the roots. I have to thank my friend Ozzy for this picture. She got it from Jim Green. So thank you, Ozzy. Jim cut every 2 weeks to 2 inches. We don't recommend that, but that's the top, and you can see what effect it had on the roots. Cutting every 4 weeks to 2 inches, you can see we have pretty good growth and a nice root system there. Now, I'm not recommending we do this every 4 weeks. To me, every 4 weeks is probably at the short rest interval for, especially for endophyte-free fescue or for friendly endophyte fescue. Kentucky 31, it's not a big issue because we're trying to suppress it, get other species in there. But for good non-toxic fescue, I would say 4 weeks is the short during the summertime, not in the spring. But I'd let that go as much as 6 weeks. And of course, for stockpiling, it may go longer than that, as you all know. It depends on what you're trying to do. Now, of course, the native warm season grasses are quite different. They're much more sensitive to defoliation. If you only defoliate 50%, the old data would show, and Joshua has the original photos of this versus the hand drawings that I have. So, but if you graze it off tight, you lose a lot of roots. Okay, let's jump into the animals. Animals, these are the primary consumers, cows, sheep, goats, whatever you have out there. Their age and production status or production rate that you need is important to keep in mind. Are they maintenance, milking, finishing? They are major contributors to the nutrient cycle, as Joshua pointed out. They do have grazing preferences that's based on animal species, but a lot of it is learned behavior. No, we didn't know about that. There's a gentleman, Fred Provenza, out at Utah State, and he has a really good website. He and his associate, it's called Behave. If you Google Behave or Utah State, you'll get their website. And they've got some really good videos and articles on how do animals learn to eat. And it's very important to understand that if you're bringing animals in from another farm to your farm. If they don't, if you have a fescue farm and you're bringing cattle in from a non-fescue farm, they're going to have a strong learning curve to go over. That's the bottom line. And it works in other directions too. So, selective grazing, there's rumen size. Okay, have you ever thought about this, that cows have 4 ways to walk? Okay, there's the single file, the cow path, old classic. Where do most of our roads follow? They follow an old cow path or buffalo trail. A grazing front, if you have 30 cows on 6 acres, they're going to basically spread out across the field and walk down the field grazing. Then they're going to turn around and walk back the other way grazing. The quiet, tight mob grazing, is high stock density. That occurs somewhere around 40,000 pounds of beef animal per acre. So that'd be 30 cows on roughly an acre, okay? They'll go into that area, they'll stop, and they'll graze. Now, they'll move a little bit, but you'll see them standing there more than walking around. And then, of course, the stampede, okay? So, we need to be thinking about animal performance, sometimes now, sometimes in the long term. Increasing nutrient requirement, we go from the dry cow that's up close to calving, the growing steer and heifer, but we're not really trying to push these animals, the early lactation beef cow, the backgrounding calf, and the finishing steer, which are basically identical to a dairy cow, where we're trying to really finish a steer or getting maximum gains on that backgrounding calf. These are the high-end nutrient requirements. These first 3, and actually I said this wrong yesterday, I had first 4. I would not push an early lactation beef cow because I want to get her bred. The most important thing on a beef operation is to get a bred cow and get her bred early in the breeding season. So the first 3, though, can be made to work. Sometime during the year. But we're going to make them work strategically, develop the forage for the future. So there are some, these are backgrounding steers, so they're not going to be mistreated. Think of forage quality as value. Value is vegetative, available, legume content, utilization, and environment. We manage value, it might be for high value or low value, to achieve our goals. Now, a lot of times we want high forage value, but sometimes we can actually have forage value that's either higher than our needs or detrimentally high. Vegetative. This is a nice vegetative pasture, high quality pasture. We have our grass, we have our legume, and we have our forb, which we often call broadleaf weeds, available. We have enough out there in front of the cattle. It comes down to pasture mass. That's why I brought the stick out here. When forage mass drops below 1,200 pounds, relative dry matter intake on that animal is going to go down because there's just not enough feed there for the animal to get a mouthful each time it bites. So at this point, forage mass is limiting. Now, all of you can figure out what that forage mass is on your pasture by having one of these cool pasture sticks. Okay? Once upon a time, I used to translate that to inches. I'm going to leave that up to you. Okay? It happens to be about 3 to 4 inches. I guess I have to say that. But the pasture sticks help us with that. L is for legumes, but now throw forbs in there. These so-called broadleaf weeds. There are some of them up there. Legumes and forbs, they decrease the neutral detergent fiber, the cell wall content. They're really decreasing it because there's more non-structural carbohydrates in there, more sugars and starches. This increases dry matter intake, and just going from a straight grass pasture to one that has 20 to 30% legumes will increase average daily gain somewhere between 1/4 and 1/2 pound a day on growing animals, not on in a dry beef cow too, but if it's a lactating beef cow or dairy cow, especially a lactating dairy cow will put out 8 pounds more milk, as opposed to 1/2 pound a day gain. So when we utilize, we don't want to graze it too tight because we want to graze it appropriate for the livestock we have. The dairy cow or a superior milking ability beef cow needs to be up in here. A dry beef cow can be working down in this region of the relative intake chart. Selective grazing. Selective grazing is the ability of an animal to select and consume forage of a higher quality than the average quality in the pasture. And I'm going to use just quality here. For a dry beef cow on a real lush pasture, what is the dry beef cow going to look for in terms of quality? It's going to look for fiber because it needs more fiber. It wants more fiber. So sometimes what we normally think of as low quality, to that dry beef cow, that to her is high quality because she needs more fiber in her rumen to make her rumen feel better. But being a person that normally likes to look at high quality feed like everybody else, let's just pick this pasture right here. This is the whole pasture TDN, total digestible nutrients of 65%. We basically went out there and cut it at ground level, put animals out there and grazed it to different levels of utilization. Where we made them really eat it into the ground, well, not really into the ground, but we used 80% of it, okay. You can see that the animals, what it appeared that they consumed was almost what was in the stand. They didn't have very much selection, did they? Their intake was about 66% TDN. The whole stand was 65. If we only made them eat off 40%, and this would be comparable to what I'd do with backgrounding calves on my farm. I'm not going to make them eat the whole thing off. So it starts out at 65, but they're going to eat 71%. Now, talking about quality, we learn from our mistakes. And one of our mistakes, we market cattle in pools in West Virginia. And there are like 14 farmers that we manage our cattle health-wise all the same way. And we wean them all the same way. And in part of the weaning and backgrounding process, they are broken to a feed bunk. So we are feeding grain out on pasture because it's part of the marketing protocol. Now, I realize a purist in the pasture business might not want to feed grain, but for every $1 we invest in grain, we make $2. So think about that. We're making money when we feed the grain. And that's long-term history. 15, 20 years. We've doubled our money when we feed grain to these backgrounding cattle. But it's part of the marketing protocol. And we're also not doubling the value. We're making $100 to $150 through backgrounding our cattle. So this is value added. that we're doing. But you have to be careful. If I have that real high quality pasture, especially you get into this quality pasture, and we had that about 2 or 3 falls ago. We had one fellow, really lush pasture, feeding the proper grain, but he had not put out any long hay for those calves to get. Now, what happens to a calf or a dairy cow if she has lush feed and a little grain? Any old dairy producers here? We've lost all of our dairy producers. It gets kind of nasty, okay. You get acidosis is what happens. And you can see if, 77% TDN plus some grain feeding and no long hay for those calves to get to, that is too high a quality. These are still ruminants. They still need fiber in their gut. And so just because of that mistake of leaving the long hay out of the pasture, and we give the hay just as a safety valve because the calf knows better than us. If they need it, they'll eat it. If they don't need it, they'll leave it alone. And they tell us what they need. But the fella didn't put it out there, and he got zero gain over that 42-day period. And I really felt bad about that because, he hadn't asked me. But I feel bad because I actually knew and was seeing how lush the pasture was. And where I was at fault, I should have sent an email out to all my county agents. And I didn't do that. I just didn't think of it. So that's on my conscience. We make mistakes, all of us do. Okay, gain per head versus gain per acre. A lot of you may have seen this sort of thing. As I increase my stocking rate on a grazing unit, the gain per head is going to go down. Over here at the low stocking rate, I'm wasting forage. Over here at the high stocking rate, I have competition for forage. Now, gain per acre initially goes up because my utilization of forage is improving more than my loss in gain per head. At some point, I reach a maximum production per acre, and then it's going to start going down. What the folks at WV have shown that if you reach this point, gain per head, gain per acre actually goes down before plant production goes down. The animal's going to get hurt before your pasture gets hurt. I'm not saying your pasture species composition won't change, but in terms of total grass production above ground, that happens somewhere over here, not in this region. On the other hand, we really don't want to be managing right there. That's maximum beef per acre. But is your goal to make maximum beef per acre or maximum dollars to the farmstead? Net income to the farmstead. Maximum net income to the farmstead happens back over here. Then if you want to manage for drought, you need to come back over here just a little bit more. If you want to leave a little bit of room there for the bad year. It could be a drought, or it could actually be an excessively wet year, because sometimes that can cause us problems. Environment. Do we have a cool fall type environment, or do you live in Harrisonburg? I'm sorry, Harrisonburg to me is the drought center of Virginia, okay? And obviously that's not Harrisonburg, but it's close to it. Okay, let's talk about botanical and season. Fiber. Now here's the grass curve. No, in the spring, okay, this is day of the year. Think of every month being 30 days, which it's close to 30 days. So the 180th day of the year, that's the end of June, the 6th month. So 30 days, times 6 is 180. So that's the end of June. So that'd be end of July and on. So anyway, In the spring, grasses have low NDF, goes up in the summer, comes down in the fall. We knew that with fescue, right? No, classic. But look at how, okay, this line here, this is clovers. Look how much lower in NDF the legumes are. And in this data, it's basically clovers. The red line is the forbs, the broadleaf weeds. Notice how the broadleaf weeds are very similar to legumes in terms of the neutral detergent fiber. Protein, our legumes are up here. Grasses are low. Protein's high in the spring, low in the summer, higher in the fall. But notice how the forbs, which do not fix nitrogen, I mean, they're not legumes, okay? Their protein is very similar to the grass. That's actually a positive out in a pasture. Because one thing is, our ruminants don't need this much protein. That's excess protein. And that causes them to lose energy as they change that protein to urea and dump it in the urine. So that's actually a plus that the forbs are providing us. They give us the low fiber, the high sugars, but not a lot of protein. Now there's the non-structured carbohydrates. This is the sugars. You can see the grasses are low in sugar. The legumes and the forbs are high in sugar. So just remember, value, vegetative, available, legume, utilize it right in the environment, but do it to achieve your goals. Not every farm is a dairy farm. Thank you. Okay, other animals in the system. Multi-species grazing, sheep, goats. More efficient forage utilization, weed control, parasite control. There are other animals out there yet. My old white-tailed deer, they're still in the pasture. I haven't gotten rid of them yet. The question is that a pest or not? For some people, it's a pest. Other people make it into a hunting enterprise. I know one fellow in West Virginia that does that. My brother does that. And actually, if you're in the right region, yes, you have to look into the insurance issues and those things, but one day of white-tailed deer hunting covers all of your cash costs in most of these places. And the rest of the days of fee hunting, that's gravy. So something to think about. If they are a pest, think about at least inviting your neighbors out for a venison dinner. These other critters may be a little more defined as a pest. Think about that one. That happens to be a vole. These are our helpers. One day I was walking a pasture of mine. It was a new seeding of orchard grass, white clover. And it was a nice stand. I had it back to 10 inches. And I was down in there looking in the stand, just feeling as good as all get out, until I found these little trails. They're microtus trails, field vole trails. And so you'd have Interstate 81 here, Interstate 77 there. And right at the corner was a little stack of white clover stolons that they'd nipped off and had stacked them right at the corner, kind of like an old-fashioned country store. Well, knowing a little bit about field mice and knowing a little bit about hawks and owls, I got my cows up there real quick and I grazed that off. Took it down to about 2 to 3 inches just to make that banquet available to these critters. And I had a nice wood line around there, and I know the screech owl was there, and I know the hawk was out there, and they cleaned up the rodents for me. The meadowlark, of course, is good for the insects. We have a number of other pasture dwellers out there. You won't have the bobolink here, but okay, soil. If you have a farm plan from the conservation district, you have your soil maps. And I do think soil maps are very important. How many of you buy a purebred bull? Let me see your hands. If you're proud of your purebred bull or ram, okay, it could be either one, okay. You probably know the pedigree of your bull and ram, don't you? Well, knowing your soil type from your soil survey, or you can go on Web Soil Survey and just find your farm on the web and read about the soils on your own farm. I think that's a valuable resource that we have today. A friend of mine from North Carolina called me up and asked me about some food plots. And I said, well, what are your coordinates? He sent me his coordinates. I was able to go on the web, find his farm, and go right down and say, well, this is what you need to know about food plots on that type of soil. So you can do that right on your own place. Now, Joshua's talking about the second herd. Let's look at the biomass of organisms above ground versus below ground. And we're just going to talk about the beef cow. On my farm, I have a standing crop of beef cows of basically 450 pounds per acre. Now, no, that is not a beef cow that weighs 450 pounds. That's a cow weaning a 600-pound calf on 3 acres for the year. And that 3 acres provides all the forage for the year. I don't make hay, in a sense. I substitute making hay for bush hogging. I make hay off of that area that can't be grazed early, and then all of the aftermath is grazed. So I only take 1 cut of hay. So all my land is pasture land. I just make the excess pasture as hay for the winter feed. So that's where that comes from. The pasture, 2,500 pounds. That's what I'm shooting for. Roughly a 10-inch grazing height. 10-inch grazing height will give me 2,500 pounds. Now below ground, I did not actually measure below ground roots, but we use the rule of thumb that there's going to be about as much root growth down there as there is top growth. So that's where that number came from. All these other numbers came from Brady and Weil in their textbook. But look at this. Bacteria, actinomycetes, almost as much as roots. Fungi, more, or as much as the roots, bacteria, and actinomycetes. Then our lesser organisms. But look at this. Look how much biological activity there is below ground compared to what there is above ground. A lot more. So we have a lot of these critters. To learn more about this, go to the Soil Food Web on the internet. But we have earthworms, one of my favorites, especially the night crawler. They give good penetration of water into the soil. We have multi-species grazing in the soil. We have multiple types of earthworms, not only species but niches, the ones that, the night crawler that comes to the surface. We have earthworms that just work manure piles. We have earthworms that just work within the subsurface of the soil. We have all sorts of insects out there. Dung beetles, we've talked about, Joshua's talked about that. The different types of dung beetles, ones that live in the pad, ones that live below the soil, and then the classic rollers out here. Snails and slugs. If we're doing reseedings, especially no-till seedings, we want to time our no-till seedings to avoid snail and slug damage. They love to get in there and eat those legume seedlings that we're putting in there. So keep an eye on them if you're doing any no-till drilling. Bacteria, major source of they decompose our residues. They help fix the nitrogen. Along with the legume, there's the nodule on the legume. You can always tell when the nodule's working if you dig up one of those plants and slice it open. If it's pink inside, it works. If it's not pink inside, the nodule is not working. Believe it or not, that pink color is hemoglobin, very similar to the hemoglobin in your blood, except it's excluding oxygen from the bacteria. That bacteria has to have the oxygen kept away from it. So it's, in a sense, doing the opposite of what it's doing for you. But that allows the bacteria to fix the nitrogen. Just to show this is protozoa, there are many different types. Many different types of nematodes. Now, a lot of times you all think of nematodes as bad, right? Root knot nematodes, you've heard of those. The root-feeding nematodes are plant parasites. They're not free living in the soil. But no, we have these roundworms. Some eat bacteria, some eat fungus, some eat other nematodes, and some eat a number of things. The fungus, they're very important in terms of decomposing older organic matter. They make a compound called glomalin that helps develop soil structure. Interactions. Let's jump over here to this little fungus. I think this is a cool fungus. This is a fungus that puts out a little lasso, and he catches nematodes, or it catches nematodes, and it eats nematodes. Here's a nematode eating, there's a nematode, and they're eating bacteria. Some eat fungus, and just pointing out that some fungus eat nematodes. So life goes around. It's a vicious circle down there. Fungus help transfer nutrients from the soil to our plants. They also will connect between plants and help transfer nitrogen from legumes to our grasses. So a healthy soil ecology, it's food supply, organic matter to those organisms down in the soil. We need the proper physical environment. We need cover. We need habitat. We need the healthy consumers up above. We need a good chemistry, soil, oxygen, pH, fertility. We need good thermal environment, moisture environment. What in the soil do we want to feed? Now, feed them and they will come. Now, you've heard the old thing, build it and they will come. Well, wildlife, doesn't matter if it's deer, rabbits, or these critters in the soil, food and cover. Those are always the first two things that you have to think about, food and cover. Now, food includes water, okay? So we have to have food and cover. We've got to have the proper thermal environment. But if we feed them, they will come. Now, don't take offense at this, but we use this in West Virginia. We have winter dinner meetings. And no, we feed them at the winter dinner meetings, right? It's the old saying, if we feed them, they will come. So it works at farmer dinner meetings too. So no offense, please take that for lightheartedness. Okay, night crawlers, they're my favorite. They like legumes. I didn't know that until I started studying this. I always knew cattle and sheep like legumes, but lo and behold, the night crawlers, they prefer legumes to grass, and young grass over old grass. Bacteria and fungus, the bacteria they do like best, or some of the bacteria like the sugars, any sugar that's there. The fungus, there's some of the fungus that'll do the sugar, but the big ticket item that the fungus do for us is breaking down the coarser, older organic matter. Just showing you from no-till research, this soil at 0 organic matter only held 10% by volume water. Increase it to around 4%, it bounced up to 25, get it up to 8%, and it was about 40. And I don't know, right here in Wytheville area, in West Virginia, 8% organic matter in the upper part of a pasture soil is not unreasonable. Excuse me there. Okay, humans, we're the predators. The big difference in us as humans is we differ in our vision, our goals, and our plans. That's what makes each of our farms so distinctly different. Depending on where we are in learning, we may have different knowledge, skills, and abilities. your economic environment, and your social environment. Those are going to have big impacts on you. So we have the science, but now we have the art and the economics of pasture management that we have to think about. So you have tools, light interception, rest interval. Is the plant tolerant to shading? Is it tolerant to frequent grazing? Residual forage mass, utilization, that's going to affect selective grazing, tolerance to close grazing. Then how we do these things, how we implement, especially the grazing process itself, stock density, grazing stay, that affects treading. So these are the big tools. How we're managing light interception, how we're managing rest interval, and how it relates to the grass species out there. How we're managing residual forage mass as it relates to the animals. You'll have different goals, high nutrient pasture versus toxic fescue management. Keep in mind, they're the basics that we want to work with. In our environment, to really do well, we do want that pH up, 6 to 7. We want the soil test in the low end of the high range with P and K. Use the proper inoculant on your legumes, especially if you're getting into a new legume type. Say if you've never grown Lespedeza on your farm, you've always had clover and you want to try Lespedeza, you've got to use a bacteria that is appropriate for Lespedeza, because clover inoculant doesn't work with Lespedeza. They're different associations. Manage the nutrients on the farm. What's the dollar value of the pee and the poo that comes out of the back end of a 1,000-pound cow per year? I want you to know that number. You want to know that number. Anybody want to guess? $55. $55. $55. Anybody give me 60? Anybody give me 60? It's $300. It's closer to $300. It's $1 a day on average. Now, is that worth managing? What's the value of a calf? Okay, a value of a good steer calf is $900. But still, that's 30% of the value of the calf. If you're not managing that 30% that you can use over and over again, is your farm going to be economically sustainable? What's the dollar value in a ton of nutrients in a ton of hay? Average, grass clover hay. It's about $60. Okay? So keep those numbers in mind as you're managing cow pee and poop and managing hay on your farm. Okay. So above ground, plants capture solar energy, animals convert it to a marketable livestock product. Both are part of the nutrient cycle. Making that, getting that material back to the soil. The surface and soil organic matter, this is the feed for the soil organisms. The soil organisms are improving the soil's physical condition. If we have a good, healthy soil, they're increasing the nutrient and water availability to the plants. Plants capture more solar energy, so we came right back up here. That's the circle of life in the pasture. So, thank you very much.